Overview. The aircraft has two separate hydraulic systems, powered by different engines to supply pressure to the hydraulically operated services. Electrical backup to the hydraulic systems is provided in the event of loss of the main engine-driven pumps. The hydraulic systems also provide a backup to the electrical system in the event of failures. This module looks at how the system works, how you operate it, and how to deal with typical system failures. The normal hydraulic system. On completion of this section, you will have an understanding of the hydraulic system components, which services are supplied by hydraulics, and how they are supplied. Components of a hydraulic system. In this section, we describe the basic components of the normal hydraulic system. The hydraulic system is divided into two parallel parts, which are designed to be kept separate. The yellow system is on the left of the aircraft. The green system is on the right. Normally, hydraulic power is supplied by two engine-driven pumps. The pumps are mounted on the accessories gearbox, on numbers 2 and 3 engines. The pumps are running whenever the engines are operating. Each pump has its own reservoir of hydraulic fluid. The reservoirs are located in the hydraulic bay. The reservoirs are pressurized using bleed air from the same engine driving the EDP. This provides a positive pressure on the fluid to the pumps, which prevents air being drawn into the system. This is known as cavitation. Each system has a switch on the hydraulics panel. The switches open isolation valves connecting the pump to its associated system services. In an emergency, pulling a fire handle will close the isolation valve. The normal system operating pressure is 3,100 psi. A relief valve, R, would open at 3,500 psi to avoid overpressure. There are no warnings of relief valve operation. That completes our look at the main components of the hydraulic systems. There are also filters, accumulators, and non-return valves in both systems. An accumulator is fitted in the yellow system for the brakes. A second accumulator can be installed for the air stairs. The accumulator in the green system assists with start-up of the standby generator. We will now look at the services supplied by each system. Hydraulically operated services. These services are supplied by the yellow hydraulic system only. You can select a service for a closer view. These services are supplied by the green hydraulic system only. You can select a service for a closer view. These services normally use both yellow and green systems because of their importance. You can select a service for a closer view. The pilot can select yellow or green pressure to power the brake system. Normally, yellow is used. Standby and emergency systems. On completion of this section, you will have an understanding of how provision is made for different types of failure within the hydraulic systems. Normally, the hydraulic services are supplied by the two EDPs as shown. We will now look at the backup facilities which supply hydraulic power in the event of EDP failure. If either EDP fails, an AC-powered pump automatically provides hydraulic power to the yellow system. The AC pump can also be used on the ground to pressurize the yellow system and therefore the brake accumulator, but not during engine start. The power transfer unit. If the number 3 EDP fails, backup is provided by a power transfer unit. Why is the AC pump now working? The PTU combines a hydraulic motor which drives a hydraulic pump. The motor is powered by the yellow hydraulic system at 3,100 psi. Output from the PTU is delivered to the green system. However, the PTU can only generate 2,600 psi. Whenever green system pressure falls below 2,600 psi, the PTU will power the green system until pressure rises above 2,600 psi. This pressure is sufficient to operate all services except the standby generator, which will be discussed later. No fluid is transferred between the systems, so the yellow system will not be drained if a leak develops in the green system. Summary. The AC pump provides backup for the yellow system. The PTU provides backup for the green system. There is an additional emergency backup for the yellow system, which we will cover next. Emergency backup, the DC pump. The DC pump is an emergency backup fitted in the yellow system only. The DC pump has its own self-contained supply of hydraulic fluid within the yellow reservoir. It can continue to operate independently, even if the main yellow system loses all its hydraulic fluid. The DC pump can be powered by the aircraft batteries. This means it will still be available even if all the aircraft's generators fail. The DC pump only provides pressure for brakes and emergency main gear lockdown. During engine start, the DC pump can also be used to top up the brake accumulator. The AC pump should not be used during engine start because it would take too large a load from the electrical power source. Summary of the hydraulic system. Hydraulic power on this aircraft is provided by two independent systems, yellow and green. Each system has a reservoir of hydraulic fluid, has an engine-driven pump to power the system, supplies a number of hydraulically operated services. Backup is provided in case an EDP should fail. The AC pump provides pressure to the yellow system. The PTU provides pressure to the green system. The DC pump provides emergency pressure for brakes and emergency gear lockdown. Backup to other systems. On completion of this section, you will understand how the hydraulic systems are able to provide a backup to other aircraft systems. Hydraulic backup to the electrical system. If there is a failure in the electrical system, the hydraulically driven standby generator can be used as a backup. The generator is driven by the green system. Immediate operation of the generator is ensured by an accumulator. The full green system pressure, 3,100 psi, is required to enable the standby generator to give a constant frequency. The only way 3,100 psi can be guaranteed is by isolating the green system from the main hydraulic supply. This happens automatically when the standby generator is operating. When this happens, the pressure shown on the green hydraulic gauge remains at 3,100 psi. However, the green system low pressure annunciator and the hydraulic warning on the master warning panel will illuminate to draw the pilot's attention to the loss of green system services. The white standby generator on annunciator on the electrics panel will also illuminate. If EDP3 fails whilst the standby generator is operating, the PTU is turned off because it is not capable of delivering sufficient pressure to run the standby generator at the constant frequency required. Summary. If the standby generator is required as a backup to the electrical system, green system services are lost when the standby generator operates. This ensures full green system pressure, 3,100 psi, is available to power the standby generator. If EDP3 fails whilst the standby generator is operating, all power to the gauges and indications on the hydraulics panel will be lost. Hydraulic backup to the fuel system. Standby fuel pumps. The yellow system provides pressure for the hydraulically driven standby fuel pumps if the aircraft suffers an electrical failure to the essential level, standby generator. With the yellow system fully pressurized, the pumps will operate automatically. Operation of the pumps does not affect operation of any yellow services. External checks. On completion of this section, you will be able to carry out the external checks associated with the hydraulic system. For hydraulics, pre-flight walk-round checks involve checking the hydraulic bay. Before entering the hydraulic bay, you should ensure that the air brake and lift spoilers are closed. The hydraulic bay door is on the right of the aircraft. Click on the bay door to continue. The hydraulic bay. When you first look into the hydraulics bay, you need to check for leaks. If the compartment is kept clean, any leaks that might occur will be more obvious. If there are any leaks, take care not to come into contact with the fluid. The system uses a hydraulic fluid called phosphate ester type 4, also known as Skydrol, which can be harmful to your skin. Each reservoir has a sight glass. The sight glass is used to check that the contents of the reservoirs are in the green sector. The exact level for the yellow system will depend upon whether both accumulators are charged. One is charged, or both are discharged. On top of each reservoir is an air gauge. Before the engines have been started, the air pressure should be at a minimum of 25 psi. There are 5 filters in the hydraulics bay. These are checked to make sure that none of the red filter blocked indicators are showing. The yellow and green system accumulators are pressurized with nitrogen. They are checked to make sure they are both pressurized to a minimum of 1000 psi. The same check would be carried out for the air stairs accumulator if fitted, as shown here. Should you find a problem with any of the components you have checked, call an engineer. Now it is your turn to complete the walk-round checks. First, locate the bay door using the arrows to rotate the aircraft. Complete the following checks. Check the green reservoir contents are in the green sector. Check the yellow reservoir contents are in the green sector. Check that the air pressure on the green air gauge is at a minimum of 25 psi. Check that the air pressure on the yellow air gauge is at a minimum of 25 psi. Check that the bay is clean, there are no obvious leaks and the equipment is secure. Check that there are no red filter block indicators showing. Check that the yellow accumulator is pressurized to a minimum of 1000 psi. Check that the green accumulator is pressurized to a minimum of 1000 psi. Check that the air stairs accumulator is pressurized to a minimum of 1000 psi. Pre-flight. On completion of this section, you should be able to carry out the checks required to prepare the hydraulic system for flight. Setting the park brakes. The park brake can only be operated from the captain's brake pedals, with the yellow system selected and the batteries switched on. The emergency brake selector switch should be at normal and the yellow brake system selected. The park brake is set by depressing and holding the captain's toe brakes. Then pulling the park brake handle up. The yellow brake pressure gauge on the captain's instrument panel shows the pressure that is being supplied to the brakes. When the engines are not running, the pressure being supplied is the remaining pressure stored in the brake accumulator. Check the DC pump. Once the park brake has been set, we continue the pre-flight safety checks by checking the functioning of the DC pump, AC pump and PTU. To check the functioning of the DC pump, the spring-loaded switch is depressed and held in the on position. The yellow brake pressure gauge, located on the captain's instrument panel, is checked. The pressure should be rising. Then, when the brake accumulator low pressure annunciator on the hydraulic panel goes out, the switch can be released. What services could be supplied with pressure by the DC pump? Click on the correct services. When the DC pump is held on, pressure from the pump is delivered to the brake accumulator and the emergency hydraulic services. Look again at the DC pump switch. Moving the bulk enables the switch to be latched in the battery position. This would mean the pump is running constantly. The battery position is used during abnormal procedures only. Check the AC pump. The AC pump switch has 3 positions: auto, on and off. In pre-flight checks, the pump is tested in both the auto and on positions. To begin the check, the switch is set to auto. In this position, the pump would operate automatically if the output pressure of either EDP is below 1,500 psi. It will continue to operate until switched off. With the switch in the auto position, yellow pressure will start to rise. Once the yellow system pressure is rising, the switch can be moved to the on position. In this position, the pump will run continuously until set to off. At about 1,750 psi, the yellow system low pressure annunciator will go out. If the AC pump is running, either in the on or the auto position, yellow hydraulic pressure is delivered to all the yellow system services. Check the PTU. When yellow system pressure has stabilized at 3,100 psi, we can turn the PTU on. The PTU on-off switch operates an isolation valve, which when selected on, brings the PTU into the system. The PTU valve annunciator is lit when the valve is not in the position selected. With the PTU switch on, green system pressure will rise. At 1750 psi, the green system low pressure annunciator will go out. The pressure will stabilize at about 2600 psi. The hydraulic warning on the master warning panel will also go out as we now have pressure in both yellow and green hydraulic systems. Which hydraulic services could be operated at this point with the AC pump and PTU operating? With the AC pump running to give a yellow system pressure of 3100 psi and the PTU switched on, all the hydraulically operated services, except the standby generator, are available for use. To finish the pre-start checks, the PTU is switched off. Then the AC pump is switched off. The PTU valve and AC pump fail lights are checked to make sure they have gone out. The AC pump fail light will come on in the following circumstances. 1. The AC pump is turned on and it fails to operate or its output pressure is below 1500 psi. 2. The AC pump is set to auto and the pump does not operate when either EDP is delivering less than 1500 psi. 3. The AC pump is turned to off and it continues to run. Complete the 6 checks as follows. Hold the DC pump on. Check yellow brake gauge. The pressure should be increasing. When the brake accumulator low pressure annunciator goes out, release the DC pump to off. Set the AC pump switch to auto. The AC pump fail and yellow low pressure annunciators should go out. Move the AC pump switch to on. Switch the PTU on. Check the PTU valve and green low pressure annunciators are out. Check the hydraulic warning on the master warning panel is out. Switch the PTU off and the AC pump off. Check that the AC pump fail and PTU valve annunciators are out. That now completes the pre-flight checks. The next section will deal with the checks after starting. However, if during start the brake accumulator low pressure annunciator came on, which pump would be used to top up the brake pressure? After starting. After the engines have been started, the engine-driven pumps, which are now running, are connected to the system. The two valve annunciators will light as long as the valve is not in position selected. If a valve fails to reach the selected position, then the annunciator remains lit. An inbuilt delay prevents the MWS giving false warnings. At this point, the low-pressure annunciators on the hydraulics panel should also be out. The system pressures should have stabilized at 3,100 psi. If we now look at the schematic view, we can see that with both EDPs on, delivering a pressure of 3,100 psi, all the hydraulically operated services are available for use. To complete the after-start checks, the AC pump switch is set to auto, and the PTU is switched on. It is important that the AC pump is not switched on before the low-pressure annunciators are out, because the AC pump would operate and remain on. A final check is needed to make sure that the AC pump fail and PTU valve annunciators are out. This is how the hydraulic panel would look during a normal flight. The hydraulic warning on the master warning panel should also be out. All standby facilities are now armed and available if required. Now it is your turn to connect the hydraulic systems after engine starting. Switch the engine 2 pump on. Switch the engine 3 pump on. Check that the system pressure stabilizes at 3,100 psi. Check that the low pressure, hydraulic warning and valve annunciators are out. Set the AC pump to auto. Switch the PTU on. Check all annunciators are out. Post-flight. On completion of this section, you should know how to shut the hydraulic system down after flight. Shutting down. During the shutdown checks, the hydraulic systems are switched off in the reverse sequence. We turn the PTU off first, then the AC pump. If the pressure drops when the PTU or AC pump is switched off, this indicates that an EDP has failed in flight. The EDP valve switches must be selected off last. Switch off the PTU. Switch off the AC pump. Switch off EDP 3. Switch off EDP2. Loss of a pump. On completion of this section, you should be able to understand the most likely causes of problems which affect the hydraulic systems, and be aware of the reasons which lie behind abnormal checklist actions. If either EDP fails, there is no annunciator fail warning to show that the pump has been lost. However, for modified aircraft, a white annunciator, AC pump on, will illuminate on the central status panel. If an EDP failure occurs, appropriate backups will operate, and the system will continue to work. The AC pump will ensure that pressure is supplied to the yellow system. The PTU will ensure that pressure is supplied to the green system. With a number 3 EDP failure, there will be a reduction in green system pressure from 3,100 psi to 2,600 psi because of PTU operation. EDP3 has been lost, so which services have been lost? Click on the correct services. Loss of fluid. Loss of a pump would not lead to loss of a system. This is more likely to be caused by loss of fluid. The initial indication would be low quantity, followed by low pressure annunciators coming on. Let us first of all deal with the green system. Loss of fluid in the green system. There is a fluid loss in the green system. The fluid loss needs to be stopped as soon as possible by removing pressure from the system. To remove system pressure, first turn off EDP3, then turn off the PTU. Switch the engine 3 pump switch to off. Switch the PTU switch to off. Finally, turn off the standby generator on the electric panel as it can no longer be used. Switch the standby generator switch on the electric panel to off. Services which use only the green system have now been lost. Now let's look at the yellow system. Loss of fluid from the yellow system. If you are losing fluid from the yellow system, again the EDP and PTU need to be turned off. But this time the AC pump must also be turned off. Services which use only the yellow system would now be lost. Services which use only the yellow system have now been lost. Loss of engine bleed air. Loss of engine bleed air pressure to the hydraulic system is another possible problem. This is indicated by the system's air low pressure annunciator and the hydraulic warning on the master warning panel coming on. We are going to look first of all at the green system. First, try to increase bleed air pressure by increasing N2 to at least 80%. Why is a positive pressure so important? If the annunciator goes out, the problem has been resolved. If not, we must turn off EDP3 to prevent pump cavitation. Turn off engine 3 pump switch. The PTU will now take over. It is necessary to make an entry in the technical log of PTU operation without air pressure in the reservoir, because cavitation could still occur in the system. In the case of a yellow air low pressure warning, the procedure is the same, but cavitation is avoided by a boost unit within the AC pump. This ensures that fluid is delivered to the pump at a positive pressure. Turn off engine 2 pump switch. Fluid high temperature. A system high temperature warning indicates that the hydraulic fluid within the system is overheating. This would require the system to be isolated in accordance with the abnormals and emergency checklist. AC pump high temperature. This annunciator indicates that the electric motor which drives the AC pump is overheating. In flight, the pump would continue to operate until switched off by the flight crew. On the ground, however, the pump would automatically shut down.